So today is the 27th day of the LeetCode 30-day challenge. And the problem will be maximal square. So we're given a 2D binary matrix filled with zeros and ones. So we ask to find the largest square containing only ones and return its area. For example, in this one, the largest square will be the red ones, and the area of the square will be 4. So how do we solve this problem? Basically, we will solve this problem via dynamic programming. But you might ask why this can be solved with dynamic programming. The first is it has overlapping substructure, as I will mention later. And for the all substructure or subproblems, they will contribute to the solution, and it will eventually give out the optimal solution. And we will repeatedly calculate the result one by one. So actually, we can build a table from the bottom up to do this dynamic programming problem. Okay, you can see here that for a given square, that the square of the red one can be actually described as the uh, green straight rectangle plus the blue rectangle minus the overlapping part, which is the yellow square, plus the bottom right square. So obviously they can be mapped to this one. So actually it can be described as this. And this for situation, the value of the bottom right, which is the area till the bottom right till the bottom right corner. The first one will be 9, the second one will be 4, the third one will be 4 as well, and the last one will be 1. So how do we analyze this? So simply we can understand that so at here we can see that the blue part is actually here, the green part is here, yellow part is here. Sorry, the yellow part is here. So and at here, this I think I don't need this one. At here, the value is 4. And here the value is also 4, or say that the side is 2 because 2 by 2 gets 4, and at this one the value gets 4. So this will be the square of the bottom right corner will be will be the square of minimum of top left and top left. Why? Because as you can see from the second one, this actually here that this one is 4, but this one contains only 1 and this one is 4. So the bottom right one cannot be 9. It must be 4. This is 9. And so for this one. And for the last one, because this one only contains 1, because none of them can form a square. This one is 1, this one is 1. So finally, the value for the bottom right corner will only be 1. So we must scan that for the length which is the side length for a square for a point at ij, where I is the row and j is column. Because the area of square equals to the length square, so the length of ij equals to the minimum of the top, the left, and the left top. Because why? As I mentioned before, that if you are not still understand, because for each square at here, what can we connect it via this square? There are three directions. The left, the top, and the top right, top left. So we will select the smaller one according to form the most possible square, because the larger one will, for the larger one, like this one, this will contain a 0, so it is not defined by the problem. Yeah. Okay, and now we can actually jump into the coding part. So first of all, let's initialize some row equals to matrix. And if the matrix is empty, we return 0. And column equals to m0 dot size. Initialize a DP array. So and this is a result for return. Okay. And this time complexity will be OM times O row times column. The time complexity will be O row times column. If this is the first row on the column, and if m@j is equal to 1, then at least 1 for the result, and assign the length as 1 to the DP, and continue. Else, if matrix equals to 1, then dpij equals to minimum of top, right, at top left, and top left. And +1 for the current one. So result is maximum of result and dpij times dpij, and finally return result to get the answer. Okay, see you tomorrow and bye.